Welcome students. So we'll take up now next chapter, that is on data structure. Now what is data structure? Data structure is a way to store and organize data so that it can be efficient. So how the data should be stored in the computer, how it will be organized such that we can retrieve it efficiently on a later date. So this data structure is a way to store. Now what are data? Data are values or assets of values. Sets of values. Data are values or sets of values. Values can be numeric or non-numeric. For example, employee of an organization is an entity. The attributes associated with the entity are employee number, employee name, employee age, employee sex, and employee address. And so many others attributes will be there. Every attribute has certain values. Attributes are called field and entity are called record. So each employee has one record. Collection of all records from a file. Certain field in the records has unique value. Such field is called a primary number. Primary key. Employee number can be a primary key. So this is the example of a data. Data are here employee data are recorded in a file, and each file and in the file each record is an employee of the company. Now each record has the records are sometimes called entity, and each entity has some attributes. They are called field. For example, employee record will have employee number, name, age, sex, address, etc. This is one of data structure. Now this file where the employee records are stored, it can be of fixed length or variable length. Now this is one way of organizing data of employee. But leaving this, this organization, data organization, we have so many. There are more complex types of structures of the data structures of there that we study now one by one. Among this complex data structure, arrays list, linked list, tree, stack, queue, graph are the different model of data structure. Among these, data structures, you have to learn details on array list. You see the array list in details, how data is stored in arrays. Now, once these data structures are defined, how the data will be stored, the next question comes: how you how you can how access those data? How to access those data? They are stored in data. The access means what? Accessing each record, searching record in the data structure, adding record in the data structure, and adding inserting record, deleting record, sorting the records, and merging them perform on the data structure. These are the data structure operations. Okay. Now when you say data structure, immediately algorithm comes because each data has its has to be accessed in different way. Depending on the data structure, you have to access the records. So algorithm is associated with data structure. Now, what the algorithm? An algorithm, finite step, a finite step-by-step list of well-defined instructions for solving a particular problem. The well-defined instruction, step-by-step instruction to solve a particular problem. Algorithms are required for data structure operation. In algorithm, purpose is first defined, variables are listed, and data are taken inputs. Secondly, step-by-step instructions exit and stop statements completes the algorithm. Most com are more most common common characteristics of algorithm is there's controls. There are some flow of control in the algorithm. They are sequential flow, they are conditional flow, there are repetitive flow. It's the This is the algorithm.
So, we'll be talking about arrays now. What is array? Array is a linear array is a list of finite number n of homogeneous data elements. That is, data elements are of same type. Homogeneous data means they are of same type. Suppose you have a data type is numeric, so all the element in the array will be numeric. Elements of arrays are referred respectively by an index set consisting of n consecutive numbers. So whenever you want to access an element in array, you have to access through index. It is referred through index. Starting from some arrays, index starts from 0, some arrays starts from 1. Elements of array are stored respectively in successive memory location. So this is important. This memory location में जो arrays elements are stored, they are contiguous. They're contiguous. एकत्र रहते हैं all. I mean, linear array में they are successive memory locations पे रहेगा all data elements. The number n is called the length or size of the array. Okay. Now how it looks in memory. Let us see. Representation of linear array in memory. LA is always referred as a linear array. So if LA is a linear array, then address of k element is location of linear array kth element is nothing but based LA. Based एलिमेंट का लीनियर एरे जो बेस एड्रेस है उससे पास करने के बाद मैक्सिमम कितना है जैसे उस के ही चाहिए तुमको के माइनस लोअर बाउंड मींस लोएस्ट इंडेक्स सपोज यू वांट टू हैव the location of third element then it should be and your address starts from 1000 plus 3 minus 3 minus lower bound means suppose it is 0 then 3 minus 0. If it starts from 1, then 3 minus 1. So that is the location of the array we will get. LB is the lower bound, smallest index, and W is the number of words per memory cell of LA. So this way we represent the array in memory. This is a contiguous memory location occupied by the elements of the LA, I mean linear array. Okay. Now, whenever you talk about any data storage, it may be for example here linear array, and then immediately it comes that how will you access the data, how will access, how will insert, how will delete. So many questions comes. Now we'll see one by one. Now here we'll see first how you access the all elements of an array, LA. Traversing array means accessing each element of the array only once. So this is the algorithm for that. Is a logic behind, logic for accessing the each element of the array. Suppose array is a linear array with lower bound LB, lowest index LB, and upper bound UB. Algorithm apply process to each element of LA is like this. First, you take a variable and lower bound you store it in K. Then this process 3 and 4 will be continuously, it will be in the loop. It's a repetitive process 3 and 4. It will go until it comes K becomes a highest index of the upper bound of the LA. K is increased by 1 here. So if you K equal to initially 1, suppose your linear array has LB1. So K will be 1 initially. And suppose your upper bound is 10, then U will be 10. So it will come to the next step. It will apply the process to the LA1. Then K will be increased by 1. So K will become 2. Now this is a loop, 2 second loop. Now so K जब 2 हो जाएगा, then it will apply the process to LA2. Then K will become 3. So it will go up again. So apply process to LA3. Like that it will go. Suppose it is 10. So suppose K becomes 10 and UB also 10. Then it will stop the loop. It will come out from the loop. So it will exit. So this is the algorithm to access a linear array. Now inserting or adding element in a linear array. How to add it? Now when we talk about adding a element, then you can add it at the end of the array. This is the original array. So the name array is there. Anil hai, Atul hai, Rajesh, Sanjay hai. Now this is blank, so you can add it here. There is no, that is very simple. Now suppose you want to add in between. Suppose you want to add millionth between Atul and Rajesh. Then what will happen? This is a complex task because in third position already Rajesh is there. So Rajesh you have to move down. Sanjay next is Sanjay. Sanjay को पहले नीचे move करना पड़ेगा. Then Rajesh को नीचे move करना पड़ेगा. Then you can store million here. So this is the complex task of adding in array. If you want to add it in the middle, this is the algorithm for adding an element in a linear array. Suppose LA is a linear array, then define a J variable and this put in the loop. This what it loop does. N is J means the highest length of the array is N. For in our case, N is 1, 2, 3, 4, 5. So N is 5. So J equal to 5. So you are moving jth element. No, you length is not 5 here. Length is 4. 1, 2, 3, 4. Because only 4 elements are there. So N is 4. So J also 4. So jth element you are moving to the J plus 1th element. That means 5th location में आप इसको move कर दिया. Then J decreased by 1. The J has become 3rd now. So insert the element. Now you new item in the kth position. So these 3 and 4 will be in the loop. it will loop until the kth positions, this kth position becomes blank. So when this when this loop is over, that means kth position जहाँ पे हमको item insert करना है, वो it has become vacant. Then you are inserting the item to the kth position. Okay, reset n plus 1 exit. So this is the algorithm for adding an element in a linear array in the middle of the array. So you can see that algorithm and data structure are, they're related. Depending on the data structure, algorithm has to be defined. Now this is the algorithm for removing or deleting item from the linear array. Now here also again same concept. If you want to delete an element from the end of the array, that is a bit simpler. That is a bit simple. But you want to delete something. For example, here you have the author. So you have to remove in between. Then what happens? All the elements below has to move up one by one. This is the same algorithm. Here, author is removed. All three elements are moved up. Okay? This is the algorithm for removing an element from a linear array. Now this is sorting of elements of array in increasing order. So you see, originally you have a list of data elements like this. How many elements are there? Elements are there. 1, 2, 3, 4, 5, 6, 7, 8 elements are there. We have to sort it. This, after sorting, it becomes this is the result. This is the in increasing order. So lowest has come first, the highest has gone at the end. This type of, you see what is the logic? What logic they have used it here? They compare first two element 8 and 4. So उसमें जो छोटा है, उसमें जो बड़ा है, उसको they push it back. So after first iteration, it will become 4, 8. Instead of 8, 4, it will become 4, 8. बाकी जो number है 19, 2, 7, 13, 5 and 16 will be as it is. Okay. This first logic, first one. Then second iteration में यहाँ पे 8 आ जाएगा. 8 and 19. उसमें जो बड़ा है, उसको पीछे push किया जाएगा. Now 8 and 19 में 19 is bigger than 8. So no action will be taken. Then next iteration में 19 and 2. So 19 को पीछे ले जाएगा, 2 को आगे ले जाएगा. 2 will come move forward by this logic. This way finally what will happen? The highest number that is in this array, 19 is the highest number. That will come at the end. When this iteration is over, this has to be again done for the balance 8 numbers. Total there we had 1, 2, 3, 4, 5, 6, 7, 8 number tha. But next time it will go for 7 numbers, 7 elements. Same way it will repeat the operations for the balance 7 elements. In that iteration, the highest number, that is 16, will come at the end. So next again it will repeat. So this way, this type of sorting, यहाँ पे this lowest number is coming top, the highest number is going down. This is what we are called bubble sort. Bubble sorting. It's like a bubble. Bubble comes to top, lowest number to highest. This is the algorithm for sorting the elements in a linear array. You have seen how have seen how sorting is done in the linear array. Okay, now we'll see searching of an element uh, element from an array. Now searching can be done. There are multiple methods are there. One method is that we'll see now is linear searching. Linear searching means this item will be compared with each element of the in the list one by one. If we found it, fine. Otherwise, it will be that I mean searched items, searched element will be displayed. So there are so it says that there are many searching algorithm. In linear search, the given element is compared with each element of list one by one. Okay, this is the algorithm for that. Here data is a linear array with n elements. This is the your program. Then this is a linear searching. Data is the element, linear array. N is the length of the array. Item means the item you are searching for. This is a location it will give. So here data is a linear array with n elements. Item is a given element. The algorithm finds the location LOC of item in data or sets LOC equal to 0 if search is unsuccessful. Suppose element आपको नहीं मिला, then location will give 0. Otherwise, it will give the location of the item you are searching. Insert item at the end of the data. Your searching that you put at the end of the data. N is the your um, length. The length is 10, so you put in the 11th location. The location now you initialize 1. Okay. Now search that item. Repeat while data not equal to data location not equal to this item. In this location, some data will be there. That item will be compared with these two. With that given item and the location item will be compared until they are same. You keep on searching. Then change the location. This is a loop. Put the loop. So first it is compared with the location one item. It didn't match. So it is gone for the location is increased by 1. So it is gone for second location comparison. Suppose second location मिल गया, it will come out. Otherwise it will go on loop. Then if location n equal to n plus 1, that means that item what you have stored at the end of the array is matching. If location is matching there and location becomes same. I mean the 11th location. Suppose you stored that item to be searched at the 11th location, and now these two are equal. That means item is not there in the original array. So set location equal to 0. That means we could not. This is an unsuccessful search. We did not find the number. If we did not find the element. So this is the algorithm for linear search, where one by one item has been compared with the given item. Okay. Now this is the binary search. This is a binary search. Binary search, what happens in what it does in binary search, the given element is compared with the middle element of a sorted list. So the two important points are here. For binary search, array has to be sorted first. Okay, without sorted binary search, you cannot. Without sorted of elements in a linear array, you cannot go for binary search. So it has to be sorted first. And in linear searching, we have seen that the given item has been compared with each element of the array. In binary search, it is not compared with each element, it's compared with the middle of the elements. So if middle of the elements compare करने के बाद, suppose it will be higher or lower. if the given item is lower from the middle element, then next search will be done in the first half of the total array. Suppose that element is given item is more than the comparatively more than the middle elements, then searching will be done in the second half of the total array. So this way, half of the searching can be, avoided. In next iteration, it will again that within the half, it will again find out the middle number, middle item. It will compare with the middle item. So this way, it will go in iteration, and you will finally find the, you can search the number if it is available. Okay. So this is the algorithm for searching an item from an array by binary search. Okay, then let's see the next one. Okay, fine. Now we have come to the, now our linear array has been discussed in length. Now we will go for pointer array. In an array is called pointer array if each element of array is a pointer. That is, each element points to an element in the another list. For example, group wise list of members. Group is a pointer array. This is a group, is the another array, another linear array. Now this is a pointer array. What happens? Suppose you have a group of 4 people. This is one array. So the index will give you the starting location of that array. Next array in the group is 3. That means next is starting from third. Next is coming 14. So 14. So there's a pointer. There are 2 array list. One array is having pointer to the another array. This is an example of pointer array. Okay, let's see next. Now, this is a representation of a record in memory. We have seen the employee record. Employee record has, so many fields like name, date of birth, age, father's name, like that. Date of birth, again, it is having date, month, and year. Now see, this record is non-homogeneous because उसमें नंबर भी है, डेट भी है, कैरेक्टर भी है. For example, name is a character field. This character date of birth is a date field. Age is a numeric field. So this is a non-homogeneous data. The record is having a non-homogeneous data. Now, how we will represent in the array now? The question comes, how we represent them in the array. So what is done for each field of the array, we are creating separate linear array. For example, name is a character. So this is now all the names will come here. Now it is possible because this is a homogeneous data type. Month is a homogeneous data type. Sex is a homogeneous data type. It may be F, it may be M, female, male, female. Okay, so when you represent a non-homogeneous data, just like a record or you have seen the record, they can be represented in the memory in a multiple linear array, in multiple linear array. Depending on the how many, if you have 10 fields, so you define 10 linear array. Okay, this is the presentation of record in memory. So we have seen linear array. We have seen pointer array, how points are, I mean, through pointer, how we can access some second linear array that we've seen. Now we'll see linked list. A linked list is a linear collection of data elements called nodes, and each node is divided into two parts. First part contains the information of the element, and second part is the link that contains the address of the next node in the list. Okay, so it will have two nodes will be there for each element. First will be the your data, second will be the pointer to the next node. Insertion and deletion are easy. It is a manipulation of link address. It does not require consecutive memory location like in arrays. Arrays में हमको consecutive memory location चाहिए था for addition और deletion. यहाँ पे addition deletion के लिए कोई continuous or contiguous memory location नहीं चाहिए. We can simply manipulate the link. Now let's see how it does. It is done. So this is the linked list representation in memory. Okay, this is a linked list. It has two parts. One is your information, and next part is have link. So we have two different arrays. A linked list can be represented by two linear arrays. Okay, these two linear arrays. One is information. This is the information. And other is link. This is a link. That is pointer to next field. So this is the pointer. Start point will be provided in the linked list. This start point is given 5. Null values link in link means end of the list. So this is your linked list. Start point 5 is given. So A is the value. Now what is the next value? That will tell this at this location. That means 2. It will come here. B is the next location. Now what it links? It links to 9. 9 is the C is there. Right? What it links now 10. 10 is the thing is there. There is a null value. So your linked list ends here. So there are 3 elements. 3 are linked like this. So here, you see number 1, they are not contiguous. Okay. Now suppose you want to add in between. So simply change the addresses. Suppose you want to add something at 7th location. D. So after C, you instead of 10, it will send to the D 7th address. Instead of 10th, you give the pointer to 7th and give 10th here to end the list. So it is so while adding, I mean, we need not push elements here and there. Simply manipulate the addresses. Similarly for deletion also, suppose you want to delete B, you simply don't give the address B here, 2 here. You give simply 9. So if you give 9 address here, so B will get cut. Okay, so deletion addition is easy by manipulating the addresses by the pointers. This is the linked list. So we have seen linear list, linear array, you've seen pointer array, you've seen linked list. Next we'll see tree list. What is tree list? Tree is a non-linear data structure. What we have seen till now, they all are linear. But tree is a non-linear data structure. A binary tree is finite set of elements with a hierarchical relationship between elements. So this is the data structure of tree, binary tree. A binary tree T has a root and remaining nodes are ordered pair. Nodes below root are left subtree and right subtree. So if this is your tree is a root, so this is the left subtree. This is the left subtree. This is the right subtree. Node with no successor are called terminal node or leaf. For example, L, it doesn't have any successor. So this is a leaf. F is a leaf, D is a leaf, K is a leaf. Two binary trees are similar if they have same structure. Okay. An algebraic expression can be represented by a binary tree. Maximum number of nodes in a branch is depth or height of the tree. For example, this tree, what is the height? Maximum number is this. Maximum number node how many? 1, 2, 3, 4, 5. So this length is the 5, or height of the tree is 5. So this is called binary tree. It's represented like this. Now, how it is represented? Link or by array. Binary tree can be represented either by link or by array. So this is a binary tree. A, then B, C. Is it okay? Now how I represent? So A is first tree, your tree. Then B, you see it goes top down, left, right. So top is A, left is B, then go C. Okay. Then B के नीचे कुछ है नहीं. So it will go now D and E. Then this two will be blank. By linked list, it is like this. The root is given at A is a root, and each element have two addresses. One is left and right pointer. Okay. Now A is having left pointer 4 and right pointer 5. Now what is in 4? 4 is in, that is B. Now B is what is the left pointer is 0, right pointer also 0, because there is a leaf, is the end of the tree. Similarly, C also, left pointer is 0, right pointer is also 0, because it doesn't have any further element. So by linked list you can represent tree like this, and by array list you can represent a tree, binary tree like this. So this is the binary tree. This is the basically just brief of a binary tree. Now comes stack and queues. Now see, when what is stack? Stack means stack you have seen. Putting one element above another. So first the zeroth element ऊपर उसके ऊपर में दूसरा element. The next is the another element. So there is a stack. That is called stack. That is also, is a way of data. This is one of the data structure stack. You have seen the stack of plates in the hotel. What happens there? First one plate is there, bottom ऊपर उसके ऊपर एक plate रहता है, उसके ऊपर plate रहता है. But when people take the plates, they don't take from the bottom. They take them from the top. So this is the example of stack. Stack structure. So that's why the structure is called what goes there last in called last in first out list. That means whatever last plate is put on the top, that will go first. Suppose then second plate will go, third plate will go, from the top it will go. So that's why it's called LIFO list. Sometimes it is called LIFO list. So stack and queue are used when you have to insert or delete at the end or at the beginning of the list. In stack, we are always adding on the top, that is at one end. We are deleting also from the one end. Okay. Now what is there is a stack. In a queue also, queue is a normal queue. You see, when you go for uh, same thing for dinner also. Your people are, all people are going in a queue. The person who at the front, he'll take the plate first. The person who is at the end, who has come last, he'll take last. Okay, so first, that's why it is called first in first FIFO. First in first out. जो पहले आया उसको पहले, he will take the first plate. So next here he will take the next plate. So in here also addition and deletion from the either from the end or from the beginning. There's no in between. Addition is not there or deletion is not there. So a stack is a data structure in which items may be added or removed from one end. That we have just explained in the case of plates on dining table. Push is used to insert and pop is used to remove from the stack. Okay. A queue is a linear list in which items may be added at the end and removed from the another end. Just like a queue in your hotel for taking lunch or in a restaurant for taking lunch, you have to go in a queue. This the queue is another data structure. So stack is called LIFO list and queue is called FIFO list. FIFO list means first in first out list. So what we have done till now is the end of chapter 2, data structure. So we have seen that array list. In array list we have seen uh, how to sort it, how to arrange it, how to search it, how insert it, the element in the array list, how to delete it. Then we have seen pointer array. After that we have seen pointer array, we have seen algorithm of course. Then after pointer array, we have seen how records are, non-homogeneous records are stored in memory by multiple linear array. Then we have seen linked list, we have seen tree structure, we have seen queue and stack and queue. Okay, so this ends your data structure chapter. Is the second uh, chapter of your software. Okay, we'll close it there now. Take care.